Next, let us take the definition of exponential distribution. So this question is appeared in examination in the year 2019 for 2 marks. They asked the definition of this exponential distribution. The continuous probability distribution in which the probability function f of x is given by f of x is equals to alpha into e raised to minus alpha x for all x where alpha is greater than 0 and f of x equal to 0 in all other cases. Then such function is known as exponential distribution. Let us here in this from this definition we can have these 2 points here. First point is f of x greater or equals to 0 for all x, because here we know f of x is equals to alpha into e raised to minus alpha x for all x greater than 0 where alpha is greater than 0. So here where alpha is greater than 0 means here it is alpha is positive. So alpha into e to the power of minus alpha x means if you take it in the denominator it becomes 1 by e raised to alpha x. So whole term is positive. Therefore we can say here f of x is greater than or equals to 0. And in second point here, second point is integration from minus infinity to plus infinity f of x dx is equals to we can divide this interval as minus infinity to 0. This is the property of a definite integral. We can divide the interval minus infinity to 0 and 0 to infinity, because here this function is defined in these 2 cases, so we can use this definition. So minus infinity to 0 means here where x is here, this is the limit for the variable x. Minus infinity to 0 means here for all the values less than or equals to minus infinity to 0. So in this case this is here first function is defined for all x greater than 0. In all other cases its value is 0. So we can take this one as 0. Plus for this interval 0 to infinity for all x greater than 0. So this is 0 greater than 0. For this interval we take f of x as this one, alpha into e raised to minus alpha x into dx, and it is equals to here alpha is independent of x, we can take it outside, and the integration of e raised to minus alpha x is e raised to minus alpha x divided by minus alpha between the limits 0 and infinity. Substitute the limits here. So first when you put alpha is equals to here alpha get cancelled, it is minus outside. When you put x equals to infinity, we know e to the power of minus infinity. You know here e to the power of minus infinity means 1 by e raised to infinity. So 1 by e raised to infinity is 1 by infinity. It is equals to how much here? 0. So therefore this becomes here, first term becomes upper limit becomes 0 minus lower limit. Lower limit is when you put x equals to 0, e to the power of 0 is 1. So thus both the conditions are satisfied in the continuous probability function. So therefore we can say that here it is, this is a continuous probability function. Next is mean of exponential distribution. We know here mean mu is equals to integration from minus into plus infinity x into f of x. So again we can divide this interval between minus infinity to 0 and 0 to infinity. So here we have x into f of x dx plus in this interval also it is x into f of x dx. Again from the definition we have seen here in the definition we know this this value when the function f of x in this interval is 0 and plus in this interval 0 to infinity the value of function is alpha into e raised to minus alpha x into dx. So let us take here alpha again a constant, we can take it as outside, and now apply the product rule for this product of 2 functions, integration for the product of 2 functions. So here it is x is first function and e raised to minus alpha x is the second function. And one I told you all of you one this one integration by parts method. We know one simple method to find the integration by parts. First function as it is, integration of e raised to minus alpha x is e raised to minus alpha x divided by minus alpha, it is divided by coefficient of x minus alpha. Then minus alternate sign you have to take here. Differentiate x, first function, that is derivative of x is 1. Then integrate this second, e raised to minus alpha x. E raised to integration of e raised to minus alpha x is e raised to minus alpha x, and this minus alpha into again coefficient of minus alpha is minus alpha whole square will write. And plus, next you have to take alternate sign, after minus you have to take plus, then derivative of this 1 is 0. So this method of finding the integration by parts is known as Bernoulli's method of finding the product of two functions between the limits 0 and infinity. Alpha as it is, first you have to substitute upper limit here. When you put x is equals to x is equals to infinity, then e raised to minus infinity becomes 0. So first term is 0. Then minus here, again e raised to minus infinity is 0, so it is also 0. Then lower limit you have to substitute. When you put x equal to 0, so this term is again 0, and lower limit means while taking lower limit you have to take this one as here, minus into minus plus. This 1 by alpha square as it is, e to the power of 0, and we know e to the power of 0 is 1. So mean mu is equals to 1 by alpha. 1 alpha get cancelled is equals to 1 by alpha. So this formula you have to remember. Next is the standard deviation for exponential distribution. And we know variance v is equals to integration from minus infinity to plus infinity x minus mu whole square into f of x dx. Again we divide this interval as minus infinity to 0, x minus mu whole square f of x dx, plus 0 to infinity x minus mu whole square f of x dx. And from the definition again we know this f of x is 0 in this interval, plus, and in this interval let us substitute the value of f of x as alpha into e raised to minus alpha x. This term x minus mu, here mu value is 1 by alpha, you substitute here. Next, again alpha is constant, we can take it as outside. Again it is product of two functions. This is first function, and e raised to minus x is e raised to minus alpha x is second function. Apply product rule. First function as it is, integration of e raised to minus alpha x is e raised to minus alpha x divided by minus alpha, minus derivative of this term, derivative of x minus 1 by alpha whole square is 2 times of x minus 1 by alpha into derivative of x is 1. Again integration of this second one, integration of second one is e raised to minus alpha divided by minus alpha whole square. Then you have to take alternate sign. I told you product of two functions, first term is plus, then minus, then you have to take plus. In this case you have to differentiate this. Derivative of 2 into x minus 1 by alpha is 2. With respect to x we are differentiating. And integration of this one is e raised to minus alpha x divided by minus alpha whole cube between the limits 0 and infinity. And when you substitute upper limit here, upper limit is infinity, so e raised to minus infinity becomes 0 first term. Then here also we have e raised to minus alpha, it is also e raised to minus infinity 0, and here also it is e raised to minus alpha, it is also equals to 0. Now come to the lower limit. So when you substitute x equals to 0, then first is here minus 0 minus 1 by alpha whole square into e to the power of 0 is 1, so 1 by minus alpha. Then when you put to lower limit, the sign of this term changes, it becomes plus 2 into x is 0, 0 minus 1 by alpha into e to the power of 0 is again 1 by alpha square. Then again plus 2, so it becomes minus because it is lower limit. 2 into e to the power of 0 is 1 again minus alpha cube. So after simplification you will get here this one as alpha into 1 by alpha cube, this one, because here this is whole square is plus and this one is minus, so it is 1 by alpha cube, then minus 2 by alpha cube, multiply these two, then plus 2 by alpha cube. So it is equals to here v is equals to take LCM. So all are LCM, this alpha cube only, we can take alpha cube as LCM. Here it is alpha cube as LCM. So 1 minus 2 plus 2, these two get cancelled, it is only 1 by alpha cube. Otherwise here also we can cancel these two. So alpha by alpha cube is equals to 1 by alpha square. So hence we know standard deviation is equals to sigma, it is equals to under root of variance v, and here we know the value of V as 1 by alpha. So 1 by alpha square, not alpha, it is 1 by alpha square. Because of this square root, it becomes 1 by alpha. V is 1 by alpha square, square root of 1 by alpha square is 1 by alpha. So from these two we can say that here the mean is also 1 by alpha and standard deviation is also 1 by alpha. So for this exponential distribution, both mean and standard deviations are equal and it is equals to 1 by alpha.